For question number 14, we've got again a smooth billiard ball and it strikes a smooth cushion at an angle alpha to the cushion. So let's make a smooth billiard ball this time, striking the billiard cushion at an angle alpha. We know that tan alpha is 3/4, so the first thing that we can do straight away, so that is 3/4, this is 5, so we get to write that sine alpha is 3/5, then cosine alpha is 4/5. The ball rebounds at an angle. Oh, okay, so this time we've got a rebound angle. This seems to be a question that doesn't have any numbers in them. Let's see. This is beta, and then we know tan beta is 5/12. So we're going to make a second triangle. Then that is beta. So this is 5, 12. So this is obviously 13. So I can say sine beta is 5/13 and cosine beta is 12/13. What do we have to find? We have to find the kinetic energy that is the fraction of the kinetic energy lost. So part A would obviously have to deal with half mv squared minus half mu squared. So it's going to be a change in kinetic energy. So we don't know what is u, we don't know what is v. So that means we will have to assume that this is u, and if that is u, I can then say the perpendicular component is u sine alpha. So u sine alpha, and then perpendicular component here would be e times u sine alpha. Parallel component would be the same, that is u cosine alpha. This would still be u cosine alpha. Right, so let's just take those guys and I'm just gonna move them here so that we can work with them slightly better. So let's move these guys here. Right, so the first thing that we know that sine alpha is 3/5, so I can now change this as u times 3/5. So which would then become 3u/5. Then u cosine alpha would similarly become 4u/5. Okay, so because that is 4u/5, I can use this one as 4u/5, and then the perpendicular component would then become e times 3u/5. But the problem is I don't know what e is. So when I'm trying to find what is v, it doesn't really help me if I use the perpendicular component, if I use this side as e times 3/5, because I'm adding an extra unknown variable. What I can use is I can use the fact that I know what is tan of beta. I know tan of beta is 5/12. That means 5 parts of this and then 12 parts of the other one. So if I take this as y and the parallel component as x, I can say tan beta is y/x, or I can say the unknown y would then be equal to x times tan beta. X I know is 4u/5, tan beta I know is 5/12, so I know that the y which I am looking for here, I can write that now as 1/3 u. So that's easy. Now that makes life much easier, because I can then work with y and x. I can figure out v is equal to square root of 4u over 5 squared plus 1/3 u squared, which would then be u times square root of 16 over 25 plus 1 over 9. So I can then say v is, what's 16 over 25 plus 1, oh, I should have used brackets, plus 1 over 9, so that's 169 over 25. So I can say the new velocity is 169 over 225 times the initial velocity. So you can see there is a decrease, and then now it's pretty easy to see that fraction is the fraction of the kinetic energy lost. And the reason is, we can now go on to say that the change in kinetic energy is half mu squared minus half mv squared. Now if I want to write that as a fraction, that will be over the initial kinetic energy. So this would again be half mu squared. So I could factor, okay, before I do the factoring part, I could cancel out all the half m, so that kind of goes off. So that would give me u squared minus v squared over u squared, and then I know that v is 169 over 225 times that. Right, I think I might have forgotten to do the square rooting part, but okay, let's see where this goes. So we've got this is equal to, so I could factor out u squared minus v is 169 over 225 u squared this over u squared. So this would then be, so essentially all of this cancels out, and then we will be left with the fraction that is 1 minus 169 over 225. So 1 minus 169 over 225, and then the fraction that we have lost is 56 over 225. So the fraction that we have lost is 56 over 225. So that is the amount of kinetic energy that we have kind of lost. So what I did, maybe the last step I kind of skipped a couple of, so I was just trying to cancel out all the u squared. So that is how I got 1 minus this, and then that is the fraction that we have kind of lost. A quicker way to think about this is, well, when we started off, as we know, the mass is not changing, so the only thing that is affecting the kinetic energy here is the velocity. So if you think about it, the velocity became 169 over 225 times the original thing. So so the amount of kinetic energy that has been lost would be 1 minus that. So maybe that's, if you don't want to think about it that way, well, you could just stick to this one, then this should be able to get you there. I think I made a mistake here when I said this should be squared. No, that I don't think that should be squared. Let's try to find out the mistake that we did. So when I did this, I squared this and I added it, and then I got I think I had a mistake somewhere here. So I did 16 over 25 plus 1 over 9. That gave me that, and I should have square rooted it, which I didn't. So v is not that. V is, right, I should square root this. So if I take my answer and if I square root my answer, I would be getting 13 over 15. Okay, so v is essentially 13 over 15. I forgot to square root it. 13 over 15u, which then means v squared would be, yeah, now this is correct, over u squared. Yeah, that is a mistake that I made. Sorry about that. So once you do that, yeah, now we've got 169, so the fraction that we have lost is 15 over, yeah. So just be careful with your math. Sometimes we, can forget to square root the thing, and then if we do that, then the whole question would have been messed up. But luckily, I somehow, I think, got away with it.